and gentlemen, with a mission to understand, explain, and improve our world and the human condition, the role of Lund University as the hosting university for MaxIV laboratory is well befitting. Let me present our first speaker, Vice Chancellor at Lund University, Torbjörn von Schantz.
Thank you. Prime Minister, ladies and gentlemen, and all friends of research and MaxIV, welcome to Lund, once Danish, now Swedish, but almost always international. And now, suddenly it's time. After many long years of research, development, planning, financing, and construction, it is finally time to inaugurate MaxIV. It is, of course, the very nature of research to be slow and difficult. A breakthrough or a complete result are never guaranteed, but that only makes the feeling of accomplishment so much greater when you do reach a successful conclusion. Today is a day to celebrate a breakthrough, a project that has evolved over decades, pushed on by brilliant ideas and united efforts. I have the privilege to be the Vice Chancellor of the host university for this particular part of the project, the part that includes festivities and celebrations, and a tantalizing glimpse of a bright future. We are here today because of the commitment of the many people who have been part of the process. Many have believed in and supported the ideas. Many have helped to create the necessary conditions for Sweden's largest ever research infrastructure. But above all, it is a small group of determined rebels in the research world who have made this possible. Because there is no getting away from the fact that MaxIV is and has been a rebel that has had to struggle to succeed. MaxIV is a project that has not conformed to academic conventions. It is an idea that has been fought for, even when there were setbacks. The government budget bill in 2008 stated that MaxIV is an important project for Swedish research, but for some reason, no money had been allocated for the project. Then there was a real concern that another major project, ESS, would hoover up the entire national budget for research infrastructure and that our own national project would be neglected. But a rebel stands firm when it knows it has a plan for groundbreaking technology. The research community, both in Sweden and internationally, has given great support. We can all be grateful that MaxIV is a challenger and that such determination has been shown over the years. It shows that the right conditions can be found in Sweden for a project of this magnitude. It is often these rebels who achieved the best results because they think outside the box and have the courage to explore uncharted territory. Even though it has caused some headaches for us vice chancellors or other financiers, we would like to thank MaxIV and all of you who are involved for being a rebel who shines so brightly. It is an honor to be a Vice Chancellor for the host university for this facility, and I'm sure that the rebel, challenger and innovator MaxIV will provide us and the world with more astonishing results than we ever could have imagined. Thank you very much.
Prime Minister, ladies and gentlemen, in a time of great global challenges, the need for research skills is constantly growing. The ultimate goal for Region Skåne is to stimulate smart and sustainable growth. Please welcome our next speaker, the chairman of the Executive Committee, Region Skåne, Henrik Fritzson.
Mr. Prime Minister, Your Excellencies, distinguished guests, ladies and gentlemen. I'm very happy to welcome all our national and international guests to Skåne. And to all of you that have moved here to work at the MaxIV laboratory, I wish you a wonderful stay in Skåne, and I hope that you will enjoy your time here. For Skåne, this day is of great importance. The MaxIV laboratory is a research facility that will be a key player in the future development of our region. Skåne has a strong research and innovation capacity. We are an international community with a global stream of people, skills, innovations, goods and services. We are confident that we have the tools we need, but we also know that it is critical to be bold and brave to maintain our status as an innovative region and to stand out among the global competition. It is our vision to become Europe's most innovative region by 2020. To get there, we will strengthen our innovation capacity and culture, a culture which grows out of the openness and diversity that we have in Skåne today. Skåne wants to attract workers into industry and public sector, bring more students into higher education and attract researchers. The innovation culture is crucial in becoming an attractive international location and innovation environment. Today, one of the world's leading materials research centers is opening here in Skåne. The MaxIV will enable researchers to explore materials quicker and at higher resolution than ever before. MaxIV will strengthen this region and, together with the European Spallation Source, it will put Skåne in a leading role for future research and innovation. Furthermore, last week we launched the news that Malmö University College will receive full university status by 2018. But it is not only about offering good facilities for study and research, it is at least as important to offer a stimulating cultural life with openness, tolerance and diversity, all of which Skåne has in high supply. We are proud to have this amazing research facility in Skåne, and we promise to do all in our power to ensure that the staff of MaxIV will have a pleasant stay in Skåne. You will make the future of Skåne brighter. Thank you.
Prime Minister, ladies and gentlemen, the vision of Vinnova is for Sweden to be a world-leading country in research and innovation, an attractive place in which to invest and conduct business. Please welcome the Director General of Vinnova, Charlotte Brogren.
Prime Minister, ladies and gentlemen, as the previous speakers, I'm also extremely happy and proud to be here after a lot of hard work and many years of preparation. Sweden has a great history of bringing world-class research into products and services, enabling companies to compete on the global market with world-class offerings. But with increasing global competition, It's vitally important that we continue to take steps to strengthen our capacity to conduct research and to innovate and to develop new products and solutions. One key element here is to provide world-class infrastructure like the MaxIV laboratory that will allow researchers to do new type of experiments delivering groundbreaking research results. But we also need to invest in the ecosystem around a facility like this so that the research results can be utilized by this industry as well as the surrounding society. For example, in developing new drugs, developing new materials from the forest industry, and very much more. Now, with the MaxIV laboratory, and in the future, the ESS, Sweden has a fantastic opportunity to do both world-leading research as well developing knowledge into new innovations. This will really create a win-win situation, both from a science perspective, but also from a business perspective. But in order to achieve that, we need even to further strengthen the collaboration between different types of research disciplines and between the different parts of the society. Access to this kind of infrastructure will make Sweden very attractive in the future for knowledge-intensive companies when they decide where to invest and where to locate their research and development. I'm therefore extremely happy and proud that Vinnova has been part of this journey to develop this fantastic site. And now when we go from construction, commissioning into the operation, we will do all we can to support that MaxIV not only provide world-class research opportunities, but also that the industry and society will make use of the opportunities it provides. Starting from September, we will even further strengthen the Vinnova organization to work with matchmaking activities between what you can offer here and the needs in the society. So, very much thank you for excellent collaboration between all the parties so far, and I'm looking very much forward to a very bright future. Thank you.
Prime Minister, ladies and gentlemen, Knut and Alice Wallenberg Foundation is one of the largest private investors in research in Europe. To see the smallest things, we sometimes need the help of very big things. Please welcome our next speaker, the chairman of the board, Knut and Alice Wallenberg Foundation, Peter Wallenberg.
Mr. Prime Minister, friends of research and science, ladies and gentlemen. As said, my name is Peter Wallenberg. I'm the chairman of the Knut and Alice Wallenberg Foundation. We are one of the main contributors to the Max Laboratory. I'm very happy to be here today. I'm happy to see so many people attending an inauguration like this. I'm happy that today MaxIV is ready. Who are we? Where do we come from? I'm actually the 5th generation of our family. I'm trying to continue a tradition that has been going on for almost 100 years. Our ambition has always been to try to help to develop Swedish science. We are, as said here before, one of the largest private research foundations in Europe, and we're proud to be that. In the original statutes of the Knut and Alice Wallenberg Foundation, which was written in 1917, it said that everything we did had to be, and we use a very British word, landsgangelikt, to the betterment of Sweden. This is what we do. This is what we use and what we have in the back of our minds when we take decisions for different grants. So it is a principle that was very important in 1917, and it is still as important. The Wallenberg Foundation is focused on basic science of the highest international standards. And we see our contribution for the MaxIV as a further way to increase Sweden's competitiveness. Our support of Max actually started 30 years ago, in the 4th generation of the family. So we've been around. We're given a lot of money. We know that the money has been used in an extremely good way. MaxIV is just to approve that what you have done is something that should be continued. We see the MaxIV as an important part of the Swedish research infrastructure. And we hope that the access to this technology will strengthen and develop Swedish science for the future. Thank you.
Prime Minister, ladies and gentlemen, the Swedish Research Council has a leading role in developing Swedish research and thereby contributing to the development of society. Please welcome our next speaker, the Director General of the Swedish Research Council, Sven Stafström.
Prime Minister, Excellencies, ladies and gentlemen, today is a great day for Swedish research as well as for the Swedish Research Council. The inauguration of the brightest light source in the world, placed here in Lund and hosted by the Lund University. The investment in the MaxIV is the biggest ever that the Swedish Research Council has undertaken. In total, we have so far contributed with a sum of 1.5 billion Swedish crowns. One of the main reasons why we starting from 2009, decided to fund MaxIV proposal was the fantastic possibilities to tackle highly relevant and important scientific problems, which, when solved by world-class scientists, will lead to the development of our society. The other main reason was the exceptional innovative design developed in-house at the Max laboratory, which results in unparalleled brightness and coherence. I have never been worried that the MaxIV team should fail in realizing the goals of the proposal, but I must say, what we see here today goes beyond our expectations. In fact, all 3 critical tasks related to any large-scale project, namely cost, time, and functionality, all are fulfilled with remarkable accuracy and efficiency. The Max laboratory started with MaxI, inaugurated in 1987, followed by its successors MaxIV and MaxIII, all funded by the Swedish Research Council. These facilities made it possible for Swedish scientists to be in the international frontline in studies of atoms, molecules, macromolecules, and materials. With MaxIV, the Swedish research community will be able to take one more major step towards breakthrough scientific results. Furthermore, MaxIV will attract the best scientists from all over the world to Sweden, and in such a way create excellent opportunities for Swedish researchers to be involved in outstanding collaborations. Yet another expectation is the involvement of industry in developing and using MaxIV. This is not only a facility dedicated to basic research, it also has the capability for more applied studies. And let us not forget about the fact that ESS is built next to MaxIV. With these 2 facilities, Sweden will have a combination of scientific tools that for a long time will put us on the global science map. I would like to take this opportunity to acknowledge those that made MaxIV possible. First of all, the MaxIV team under the excellent leadership of Christoph Quittman, and by the exceptional ingenious design by Mikael Eriksson. I would also like to express my gratitude to Lund University that serves as an excellent host for the MaxIV, as well as being one of the main funders of the facility. In a small country such as Sweden, it is important that research funding organizations sometimes join forces, and I think that the investment in MaxIV is a very good example of this. The investments made by Vinnova and several Swedish universities have been extremely important. Furthermore, initiatives, investments, and last but not least, interest from the Wallenberg family have been absolutely critical for MaxIV. To end, I would also like to mention the critical role played by the Swedish government. Our investments, the Swedish Research Council investments in MaxIV, have of course been supported by the government. And there are also substantial contributions from the government specifically directed to MaxIV. Now I'm looking forward to further discussions how all of us can contribute to the brightest possible future of MaxIV. So let there be light. Thank you.
Thank you to all our speakers for sharing with us your thoughts this day. An applause. Thank you. Now, it's time for us to take our seats at the ceremony hall.
Science today has some monumental challenges to tackle. Scientists have to develop new biofuels for our environment, for example, and new antibiotics to combat increasingly resistant bacteria. Achieving this requires more studies of our material world on a molecular level. But to see the smallest things, we sometimes need the help of very big things. Things like the massive structure emerging just outside of Lund, Sweden today. It is a super microscope. You could say it works like a big X-ray machine. But unlike the one used in your local hospital, this one utilizes a light which is so intense that it can show things which are almost invisible. Small material components such as molecules and atoms. This light is called synchrotron light, and it plays an indispensable role for many major fields of research.
What we are doing here is to try to look a bit deeper into the invisible world, because we understand more and more how powerful this world is. It has a very strong impact on our lives, for our health, also our living standard, the economy, and of course also for the environment. We are of course very interested, trying to understand how it acts, and hopefully in the future that we can have an impact on it as well.
The new laboratory for seeing the almost invisible is called MaxIV. It is going to be the world's most brilliant synchrotron light laboratory, built with the help of the Knut and Alice Wallenberg Foundation. The man responsible for the laboratory's new innovative technology is its machine director, Mikael Eriksson.
What will happen is that MaxIV will be the first very high brilliant source. And that will give us a possibility to just see things which haven't been seen before.
MaxIV is as large as the Colosseum in Rome, but it isn't built for gladiators. It was built for electrons. Electrons are accelerated to near light speed in a tunnel. Then they are led into a large ring where they swirl around with the help of magnets, causing these electrons to emit a very intense light, a synchrotron light. The radiation from the accelerator can be dangerous, but today it is turned off, and Mikael can take us to the other side of the meter-thick concrete doors.
So what we're seeing here is the tube in which the electrons are traveling with the speed of light. This tube is very tiny compared to what we have today. This is in fact only some 2 centimeters in diameter.
In just one day, each of the electrons in the narrow tube spin around nearly 50 billion times. Holding them in the right place and keeping them from crashing into the walls of the tube is achieved by using many magnets with different characteristics.
And most important are the dipoles here, which bend the beam slightly. And we have 140 of those dipole magnets, and together they form a closed orbit. So the electrons can go round and round and round and round.
These different magnets play a central role in this state-of-the-art facility. But the history of MAX began quite simply. Over 30 years ago, Mikael was there for the building of the very first MAX laboratory, which was more or less a homemade project.
The first machine, which was called simply MAX, was almost completely home-built. So we had to find cheap solutions all the time.
And there was a great amount of ingenuity. For example, when the scientists even borrowed a clothing press or wringer from the mother of one of their colleagues to glue the magnets together.
Put the epoxy glue on the rolls, put in the plates, and had a serial production of magnets. And that worked beautifully, except for one sad thing. The wringer was completely destroyed afterwards. I never dared to visit him after that.
In spite of the low budget, MAX 1 was a success and paved the way for MAX 2 and MAX 3, all supported by the Knut and Alice Wallenberg Foundation and all under Mikael's supervision. MAX 3 served as a testing facility to bring forth new technology, which now will help the full-scale MAX 4 to be a world leader. One part of this involves using smarter magnets. Whereas previously a few large magnets were used, they have successfully developed several different kinds of smaller, more effective magnets. The greater the number of magnets that will fit into the available space, the more focused the electron beam will be, and the more intense the light.
In the very start, I must say that we were afraid of that technology. Our colleagues were skeptical, to say the least, but and that turned out to work quite well.
With the help of those new magnets, the light beam from MAX 4 will be 10,000 times more brilliant than that of the MAX lab today. And in doing so, it will lead the world. This is important, as the competition for attracting the leading scientific minds of today is fierce.
It's so that the best researchers are often very demanding, so you've got to have an equipment which is first class, preferably best in the world, of course. It's not only the accelerator, it's the beam lines, it's the end stations, it's the computer facilities, it's the detectors, name it. You've got to have strong links in all the chain.
It still looks a little desolate, but MAX 4 will soon be filled with scientists from all over the world. It is expected that there will be 2,000 researchers visiting per year, coming to work at the various experiment stations. The synchrotron light will be channeled from the big ring via beam lines and sent to different specialized experiment stations. There, teams of researchers from diverse fields will use the light to investigate their materials. One of these stations is Biomax. Thomas Ursby is the project manager here.
So now we're arriving at Biomax and the orange radiation protection area. So we have the beam, the X-ray beam coming out from this wall, going through this vacuum pipe, and comes to a vacuum chamber, which is the mirror chamber. So there are two mirrors, and the purpose of those are to focus down this X-ray to a very small beam, which is about the same size as the sample, which is in there. So we're still lacking some of these vacuum pipes to come into the experiment hutch.
When all the parts of the beam lines are in place and Biomax is ready, it will be used as a specialized experiment station for studies in structural biology. Among other things, this includes the study of how proteins are built, which can play a crucial part in the production of new medicines. The scientists will come here with the protein samples that they want to have a closer look at.
So the X-ray beam comes into the experiment room in here, and then we have a sample that sits in one of these standard sample holders. So on the tip of this needle here is the actual sample. It is then rotated. So we have the X-ray beam hitting this sample, and it's scattered out.
When the X-ray beam hits the proteins, it is refracted into a specific pattern. From this pattern, a computer can calculate and render a three-dimensional image of the protein. Among other things, this can show the exact locations of the atoms in the protein, knowledge that can help in developing drugs that work more effectively in the body. One of the researchers waiting for the completion of the installation is Maria Selmer from Uppsala University. She is researching proteins and antibiotics and the problem of increasing resistance of bacteria to our current medicines.
We want to understand antibiotic resistant enzymes and how they can modify or degrade antibiotics so that they no longer have the desired effect. To understand all these processes at an atomic level, we need very intense X-rays.
With MaxIV providing the world's most intense synchrotron X-ray light, Maria is hoping to make new advances in her research.
I think it will lead to better understanding of the detailed processes of life and ultimately to the development of new and better antibiotics.
For Mikael Eriksson, MaxIV will be his last big project. Once the facility is up and running, he will retire. Mikael has devoted his entire professional life to synchrotron light, and he sees great potential for MaxIV in the future.
It's no secret that we have quite large challenges ahead of us. It's a growing population. This planet is getting more and more dirty. It has an effect on the climate, and one can at least dream of that we can contribute to a more positive development. We have always seen how technology is driving science, as science is driving technology. But this is an interaction which is most exciting, and it will be quite exciting to see what will come.
Prime Minister, ladies and gentlemen, His Majesty, the King.
Det som är speciellt med MaxIV är att vi här producerar ett ljus som kallas för synkrotronljus och som i vårt fall är väldigt briljant. Att vara mycket briljant betyder att man producerar mycket ljus, det är väldigt intensivt. Men inte bara det, utan också att den ljuset kommer från en källa som är väldigt liten i tvärsnittet. Så ytan är väldigt liten. Och också divergensen på det ljuset är också väldigt liten. Och det betyder att vi kan transportera ljuset och fokusera det ljuset på väldigt små provbitar på ett väldigt effektivt sätt. Och det är det som attraherar många forskare som kommer hit för att använda det ljuset för att studera olika sorts material.
Vi här i Lund hade en stor elektronaccelerator som heter Lucy, och sedan måste man göra besparingar i det projektet och man bestämde sig för att lägga ner anläggningen. Själv var jag projektledare för en grupp på 25-30 personer och vi stod plötsligt utan resurser och utan möjlighet att komma vidare. Vad gör man då? Jo, man hittar på något nytt. Och det vi hittade på var att göra en billigare maskin, bättre maskin och göra en bättre forskning. Och det projektet döpte vi till MaxIV-projektet.
Max har ju en mamma. Hon hette Lucy. Det var en tidigare accelerator här. Så infrastrukturen fanns på plats. Det vill säga kunskapen hur man gör acceleratorer. Det fanns mycket material, framförallt utbildad personal. När sen den stora röntgenboomen, synkrotronljusboomen kom, då var vi rustade och kunde sätta igång.
Det mest intressanta forskningsfältet vid denna tiden var faktiskt kärnfysik. För jag var kärnfysiker och min grupp var kärnfysiker. Så vi skulle göra någonting väldigt bra, väldigt nya. Men det drog också blickarna till sig från annat håll. Från Uppsala i första hand, men också från Göteborg och från Linköping. Det kom forskare och frågade om man inte kunde utveckla hela systemet till att också innefatta synkrotronljus.
Redan vid Lucy så fanns det en synkrotronljusverksamhet. Det var några forskare som gjorde experiment vid Lucy. Det var inte lätt. Det var ingen lämplig maskin för det. Intresset fanns. När vi sen satte igång Max-projektet hette det på den tiden, det fanns inte de andra, så kom förslaget att vi också skulle lägga in en möjlighet att framställa synkrotronljus vid det som senare blev MaxIV.
MaxIV kom till på det sättet att vid den tidpunkten, det var ju omkring 1990, så hade det skett en utveckling inom det här fältet. Så det nya med MaxIV var nästa steg i utveckling, vad vi kallar för undulatorer, magnetiska insättningselement på maskinen som ytterligare gav ett par storleksordningar mer i intensitet. Och det betyder att man kan titta på mindre strukturer. Det blir mikrostrukturer, mikrodiffraktion, mikroabsorption. Och det är ett viktigt område då det gäller de nya forskningsmöjligheterna.
Ja, den största utmaningen var ju naturligtvis att få hela MaxIV-projektet etablerat.
Det var två mycket stora utmaningar när jag började som forskare på MaxIV-laboratoriet. Det första var att få skaffat pengar till strålrör. Och där hade man fått möjlighet för att skicka in en förnyad ansökning till Wallenbergstiftelsen. Men det var med den klausul att det skulle vara stöd för svenska universiteter. Och det ansåg jag för att vara ganska vanskligt. Men jag var meget glad, da det lykkedes at få midler for de svenska universiteter, så de första 7 strålrör var garanterade.
Ja, för att etablera ett sådant projekt så är det naturligtvis oerhört många steg. Man måste ha med hela forskarsamhället i landet. Det gällde att få med forskningsrådet och sen naturligtvis att tillskapa hela den tekniska designen.
Vår största utmaning har varit att tillsammans med alla dessa experter på olika tekniska system på MaxLab att se till att få allting att fungera samtidigt tillsammans. Och vi var ju dessutom, linjäracceleratorn var det första projektet och vi var först ut på MaxIV. Så vi har ju varit pionjärer när det gäller att ta oss an alla de här utmaningarna som hela MaxIV-laboratoriet har stått inför.
The biggest challenge was to manage a project of huge complexity where scientists, engineers, but also politicians and financiers need to work together. This is the biggest thing that Sweden has ever done. This is the biggest thing that any of us has ever done. Keeping people focused was a big task.
Nästa utmaning för MaxIV det är först att använda det här, den källan som vi har just byggt och producera utmärkt vetenskapliga resultat med det.
MaxLab etablerade sig oerhört väl när det gällde spektroskopi på ett tidigt stadium. MaxI och MaxII. Och faktiskt var det så att det gjordes verkligen världsledande forskning här i ytfysik, atommolekylfysik med mängder av nya resultat och som blev någon sorts standard för världen vad man skulle uppnå. Och det här är ju då oerhört viktigt för att om vi nu tar ytfysiken så knyter det ju an till många praktiska frågor. Till exempel då, vad sker i detalj i en avgasrenare till exempel?
Den största utmaningen för framtiden är utan tvekan miljöfrågorna. Jag tänker på mina barnbarn, men kanske ännu mer på mina barnbarnsbarn som kan befinna sig i en väldigt besvärlig situation om vi inte tekniskt och vetenskapligt löser de riktigt stora frågorna. Och de stora frågorna är av alla möjliga arter och därför behövs det ett mångfacetterat laboratorium som kan angripa miljöfrågor från olika håll.
Något som ju är viktigt idag är ju batterier, batteriteknologi. Att förbättra sådana här litiumbatterier så att man kan ladda dem ännu bättre, att de räcker längre, går snabbare att ladda. Och de skulle vi kunna studera på strålröret här och göra det när de verkligen fungerar också, så när de är i drift.
Jeg arbejder med strukturen af proteiner, og det kan være vanskeligt at få store nok krystaller til at lave et eksperiment. Men med MaxIV kan vi studere meget små krystaller og dermed få oplysning om proteinernes struktur.
Jag hoppas verkligen att vi kan få mer information om membranproteiner. Och de är väldigt viktigt för kommunikationen utifrån cellen, inne i cellen. De sitter på kanten. Och vi vet väldigt lite om de grupper av proteiner och de är väldigt viktigt, inte minst för medicinutveckling.
Det som den största utmaningen som ligger framför oss är att vi ska få den här linaken att kunna leverera precis enligt sina specifikationer och leverera så hög kvalitet på elektronstrålen som den är specificerad för. Det vill säga att den ska kunna leverera stabil elektronstråle till 2 stycken lagringsringar och samtidigt kunna producera korta intensiva elektronpulser till kortpulsfaciliteten. Och se till att vi kan uppfylla alla specifikationer som vi kom fram till designen på linaken.
My hope is that MaxIV can realize its potential as the brightest X-ray light source in the world. Light has revolutionized our understanding of the world surrounding us. This light source here will allow us to study materials as they occur in nature, but also materials that we make to make our life better.
Om jag ser framåt så ser jag väl ett labb som kommer att fortsätta att utvecklas. Man kommer att hitta nya lösningar. Det kommer att byggas upp nya strålrör. Det kommer dessutom att bli förbättringar av anläggningen, det är jag övertygad om. Det har varit utmärkande för MaxLab tidigare, det kommer att ske nu också.
Det jeg ser fremover, det er at se denne hal fyldt med fantastiske strålerør, hvor vi kan lave helt unikke eksperimenter, som aldrig er blevet lavet før med synkrotronlys. Og jeg tror, at vi kan forestille os noget nu, men jeg tror, at vores fantasi har ikke muligheder. Der vil komme fantastisk mange spændende ting, hvor man udnytter den høje brillians at lave imitans af MaxIV-laboratoriet. Og jeg tror, det vil komme inden for kulturarv, også inden for områder, som vi ikke tænker på i dag.
Det jag skulle önska det är ju då att en stor mängd unga forskare har möjlighet att komma hit på samma sätt som vår generation hade möjlighet att utnyttja MaxI och MaxII. Då kommer det att bli väldigt bra forskning här.
I would wish that many young and enthusiastic scientists come here to do experiments that they cannot do anywhere else, that they find out the secrets of nature that they long to uncover, that this becomes a meeting place for people in physics, chemistry, for people from Sweden, the Nordic countries, the rest of Europe, that it becomes a hotspot in science.
Det är ju helt klart att den resa som inleddes på 50-talet, att man började använda acceleratorer för röntgenframställning, har ju varit fantastisk. Jag tror det är 6, 12, 10 potensers ökning i prestanda. Och vi är inte framme vid den yttersta gränsen än, men vi tror att vi vet hur vi ska göra för att nå dit. Framtiden för acceleratorer i de här sammanhangen ser väldigt ljus ut.
För mig så har det varit en fascinerande resa, men det allra mest intressanta ligger fortfarande framför oss.
Your Majesty, Prime Minister, County Governor, and ladies and gentlemen, please welcome the Director of MaxIV Laboratory, Christoph Quittman.
Your Majesty, County Governor, Vice Chancellor and funders, dear guests and colleagues, I welcome you to the inauguration of the MaxIV facility on the day where the sun reaches the highest point over the city of Lund. Today, we are opening a window to the future. We're inaugurating the tool that makes the invisible visible. Since more than 30 years, scientists in Lund have built instruments to help their colleagues investigate how atoms form molecules, how molecules form crystals, and how we can use crystals to improve our everyday life. We have looked into questions as diverse as new states of quantum matter, nanowires, and better drugs to help to cure diseases. We have watched atoms form molecules in a split second, and we have studied pieces of the Vasa ship to help conservationists preserve it for centuries to come. X-ray light has given us an understanding of nature's secrets, allowed us to explain them, and helped finding ways to apply them to everyday life. Many young researchers started their careers here in Lund. They were driven by their curiosity and by a passion to find answers to questions almost impossible to answer. They were fascinated by the high-tech tools and driven by team spirit. Almost all of them have continued their careers successful outside of Lund, some outside of Sweden and a few even outside of Europe. But some of them stayed on and became leaders propelling the team to ever higher levels. On Lucia Day 2015, it was two of these old-timers who had the honor to turn off the previous machine, which after 30 years of operation had lost its competitive edge. Today, all of us are here to witness the inauguration of the new facility, MaxIV, with which Sweden takes the lead in the international competition for the brightest scientific tools. Welcome to all of you who have come here from near and from far. We are so glad to have you as our guests today, and we hope to see many of you in the future as users exploiting the unique potential of this bright light source. Let there be light.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Thank you for entrusting me this precious light. After so many years of enlightening our scientific understanding, it shall now rest with me. Call me when you're ready to take the next step. I shall come and return the light to you. against. Tell me what was real. When darkness is by your side, the fire burns, no ashes found. Hell is young, reaching higher. Right up the sky, reflect the beam of light. Evolution takes me higher. If we're aligned, when worlds collide, we're rising. Elysium. In Elysium. There is a galaxy hidden in every sound, sitting underneath the surface of the shell. Illuminate the sky with your mind. Thrive within the circle of life. Oh, Elysium, reaching higher. Right up the sky, reflect the beam of light. Evolution takes me higher. If we're aligned, when worlds collide, we're rise. Let it be like, 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 let it be like in Elysium. Elysium, reaching higher. Right up the sky, reflect the beam of light. Evolution takes me higher. If we're aligned, when worlds collide, we're rising. Elysium. In Elysium.
Your Majesty, County Governor, ladies and gentlemen, please welcome Prime Minister Stefan Löfven.
Your Majesty, Excellencies, international guests, ladies and gentlemen, I am very pleased, not least on behalf of our international guests, to welcome you to Sweden at the very best time of the year, midsummer. In a country where we sometimes joke and say that the summer can be counted in days, if not in hours, we take every chance we get to enjoy the sun. This is a time of year when the Swedish people come together and celebrate the light. And midsummer has become a national holiday, probably the most favorite one of all. And today, the 21st of June, at exactly 1300 hours, 8 minutes, and 55 seconds, the sun will reach its highest position in our sky and shine more brightly than on any other day of the year, although you might question that today. Could there be a better time to inaugurate MaxIV, the brightest light source of its kind in the world? This inauguration makes history, and this is, in the truest sense of the word, a moment of enlightenment. As a global community, we are facing huge challenges when it comes to our natural environment, climate, and also the health of our people. Facing these challenges, the brilliant lights of MaxIV will enable humanity to see things never seen before. Synchrotron radiation technology has already helped humanity in everything from development of catalytic converters in our cars to the understanding of insulin in our bodies. The potential of next generation technology is enormous and impossible to fathom, as none of us know for sure what we might discover. But what we do know is that the research that will take place here at MaxIV can lead to groundbreaking advances in the fields of biology, physics, chemistry, and medicine. Here, on this spot, we can create new tools to meet and overcome the challenges confronting our world. And in these days of war, tension, and uncertainty, the light and hope of science is perhaps more important than ever. At times like these, it is crucial that we push on and dare to invest in things that do not bring immediate benefits and where the output is not known. It is an uncertain venture, yes, but throughout history, the common denominator of human progress and evolution is the audacity to look into the future and plunge into the unknown. MaxIV is a symbol of that, what my government is striving for Sweden to be. We want to lead, to launch new endeavors, to deepen human knowledge in cooperation with others. We hope that MaxIV will be an investment from which Sweden, together with others, will profit in many more ways than just financially. We wish to attract the very best researchers from around the world, but we are also looking forward to Sweden providing MaxIV with many great new talents. And we hope that young people here in Lund, in Malmö, and all around the country will aspire and long to join your ranks. And we promise all of you who want to participate in the possibilities that MaxIV brings, that we will also invest in the supply of knowledge and infrastructure of education and innovation that are crucial to maximize your efforts. The Swedish model is based on solidarity and teamwork. We will create the light together. Ladies and gentlemen, in my life, I've often seen and felt the darkness in society labeled unemployment. Long-term unemployment is like a dark hole that destroys hopes and dreams. It crushes self-esteem. Now, science's role in society is to question and to explore. But I also hope that MaxIV will generate new innovations that will help to create new jobs and by that also bringing new hope. Although Sweden now has the lowest unemployment rate in 7 years, many of us are still waiting for that call and want to step into the light of a new working place. To conclude, I would like to say this. The only thing we can know about the future is that it is unknown and that it will be different. Most of my working day goes to strengthening our society's ability to constantly adapt, upgrade, and innovate in the face of an ever-increasing global competition. We're focusing on our country's efforts on boosting education, investing in teachers and specialists, and expanding everything from preschool to higher education. We have established an innovation council which is working with representatives of business, trade unions, the research community to pave the way for development and growth. And we are trying to create a regulatory framework that supports and encourages the development of the successful business models of tomorrow. But our role as politicians and investors is only to create opportunities for others, for all of you, women and men who proudly spend your life helping the lives of others. So let me congratulate MaxIV Laboratory that through many decades of hard work and excellence has laid the way for this extraordinary synchrotron radiation technology and the scientific use of it that makes MaxIV possible. I want to thank all of you who are participating in this project that boldly shines its beams into our uncertain future. As the Prime Minister of Sweden, I'm very proud to announce that the world's foremost research facility of its kind is now to be found in Sweden. But as a human being, I'm even prouder that this new ray of light is now to be found in the world. Thank you very much.
Your Majesty, Prime Minister, County Governor, and ladies and gentlemen, please welcome Professor Maria Selmer, Uppsala University.
Your Majesty, Mr. Prime Minister, County Governor, colleagues, ladies and gentlemen. It is a great honor to stand here as a representative of all the scientists that for many years have looked forward to the day when MaxIV would open and we would get access to this amazing facility. I will do my best to explain to you how, from my perspective, this facility will make a difference for science and for the society. I will also give you a personal tale of some aspects of the life of a synchrotron scientist and the mother of children who happened at an earlier age than their friends learned the word synchrotron. Synchrotron light can be used in a number of different ways by academia and industry to figure out the properties of samples, ranging from naturally occurring or man-made materials to living organisms and to biomolecules that we study in my research group at Uppsala University. The experiments tell scientists about different length scales and about time scales ranging from several 100-million-year-old fossils to chemical reactions on tiny fractions of seconds. And we gain information about chemistry, physical properties, or what the samples look like inside. This building is a place where basic science, striving to understand phenomena of, for example, physics, chemistry, biology, and medicine, intermingles with and leads to applications such as development of new materials for energy production and batteries, and new drug molecules that can cure diseases. We cannot predict which discoveries in basic science that will lead to innovations that change the society, but I think there is a very good chance that MaxIV can make a difference here. I am a structural biologist and X-ray crystallographer. In this type of science, we visualize large molecules of life at a level where we can see what they look like, their structure, and draw conclusions on how they work. This means that I use atomic-level images to understand how things work in the life we observe with the naked eye or with a normal microscope. Our synchrotron experiments allow us to visualize where in our study object there are more or less electrons. To for the first time see these results from a new sample can for me be the equivalent of when a famous archaeologist opened the grave of Tutankhamun and saw wonderful things. I will never forget the first time I, at a synchrotron, could visualize my first protein and start understanding how it worked. A main goal of my research is to understand different aspects of ribosomes, machines that in each living cell make proteins based on information in genetic code. Inside the cell, they are large, but we could in theory line up 50,000 of them in 1 millimeter. Many antibiotics work by stopping this machinery in bacteria, but not in humans. With the power of a synchrotron, it can be visualized how a clinically used antibiotic fits in a single site of this huge molecular machine. This is equivalent to if the chairs in this room were tailor-made to only fit one person in the audience. And you can probably imagine that we would need very detailed information to figure out where someone, or in our case, the antibiotic, would fit. Here at MaxIV, we will continue our quest to understand life, and in particular antibiotic resistance, at an atomic level, and hope to be able to combine different types of experiments and to make movies as well as still images. This may also lead to identification of new drug targets that can be explored in antibiotic research. You may wonder what it's like to be a synchrotron scientist. It is almost 20 years since I first set my foot in a synchrotron at Max2 here in Lund when I was a PhD student. Since then, synchrotron experiments have enriched my life with moments of joy, disappointment, struggle, sleep deprivation, friendship, and not least, scientific insights. Synchrotron experiments are different in character depending on the area of science, but in many areas, experiments go faster and faster when synchrotrons become more powerful. To illustrate this, my PhD supervisor here at Lund University used to tell me stories about his family vacations in a cottage in a small village in England, which happened to be the home of a synchrotron where he could collect data during the holidays. During my PhD and postdoc, we would typically collect data on each sample for a few hours and spend 24 hours on a synchrotron. During the night shifts with an international team of scientists and students, we would not only solve technical problems and make sure that our experiments worked fine, but also discuss how to solve the world's problems, listen to people's favorite music, make friends, and eat too much snacks to keep us awake. During the last 10 years, technical developments have speeded up experiments, and at MaxIV, each of our typical experiments will be done in seconds to minutes. We will also be able to do some of our experiments remotely from our office in Uppsala. We can combine clever advice from foolproof software with our knowledge of the methods and the systems we work on to optimize our experiments. This also allows us to spend more time on the challenging preparations of the very best samples to make the best use of our experiments. We will for sure be too busy to solve the philosophical problems of life during our experiment, and we'll have to resort to doing that when we have time for a coffee break or meet to celebrate our newest results. So what can we achieve with this large, excellent instrument? Scientists from Sweden and other countries will send in their best project ideas, competing for experiment time. I hope that in 10 years, we will see experiments and results that we currently can barely imagine, and that we can also communicate the impact of this facility to the people who drive past every day and just see a large circular building resembling a spaceship. Together with the scientific community, I'm very grateful to the funders that have made this possible and to everyone who has contributed to the design and construction of this fantastic facility. To end, I wish that the light from MaxIV will allow us to understand our planet and its life and to make our future brighter.
Prime Minister, County Governor, ladies and gentlemen, please welcome His Majesty the King.
Prime Minister, County Governor, and all scientists who are gathered here today. Well, today we are going to inaugurate MaxIV, a unique facility providing the brightest X-ray sources in the whole world. Here, many different actors in public and private sectors have joined hands. Sweden, Denmark, Finland, Estonia are all represented among them. This joint investment will benefit not only this region, but the whole, I would say, global society. It is a well-established fact that the challenges we face today are seldom limited by natural borders. Instead, they are often truly global. This is especially true when it comes to the environmental concerns like climate change, pollution, declining biodiversity. These challenges are global. They affect us all, and they also demand of us that we cooperate across borders. Therefore, it is very encouraging to see that MaxIV is attracting interests from scientists all over the world. I must say I really look forward following the work in the coming years and to learn about groundbreaking development in areas like water treatment or energy efficiency. To build a sustainable future, we need to develop new materials that are environmentally friendly. For example, by inventing new products based on the Swedish, well, maybe forest. So I am glad that that important steps in that direction will be taken here within industry and academia in close cooperation. So now the light has returned, but before we can turn on the accelerator, we need to close the doors to the store ring which is surrounding us. I will therefore ask the Prime Minister Stefan Löfven and Director Christoph Quintman to join me and help me to close the last door, which is now open. Well, let's follow me and see what's happening.
Take me to inner space, defying gravity. Before it all begins, tell me what was we. The darkness is worn by your shine. The fire burns, no ashes found.
a galaxy hidden in every cell, seeking underneath the surface of the shell.